Garage door. Automated. Wow. Such power. And just at the press of a button. But maybe we could do such a similar project using Internet of Things device, like an ESP 8266. To the bench. Let's see what we can do. What do we need to IoT this? An IoT device, ESP01 sitting around here, so that's a starting point, I guess. We'll probably need a motor of some sort. Let me see. Do I have... Oh, here we go. We've got a motor here, which is... I found this actually at a recycling centre. So it's 24 volts DC. Probably doesn't work. Testing with 15 volts. Okay, so it does work. Motor's probably going to run at about 12, 15 volts, something like that. This one here, 3.3 volts. Okay, buck converter to take it from 15 to 3. Well, maybe to actually take it from 15 to maybe something like 7 or 8. And then one of these LM117 3.3s to take it down to a nice steady 3.3 volts. And a big capacitor in there as well, which I don't have handy, but yeah, maybe something like a 1000 or 2000 farad capacitor, because when something talks to this, it does draw a little bit of extra current, so it's nice to have handy. So to program the ESP8266, that little guy there, and then to put it onto a breadboard, because we'll breadboard it all up, will be this little converter or adapter. But how to talk to LEDs. So if I put these LEDs and there's some current limiting resistors, I'm going to run into a problem because the ESP01 doesn't have that many outputs. So we're going to need something to talk between this one and, well, firstly the LEDs, which are fairly low current, but then this monster, that could be interesting. What I might do is maybe try a CD, actually it's a 74HC595, which is shift register. So we've got ESP01 to shift register to these guys here, and then maybe out to a ULN2803. The advantage of this is that you can put a reasonable amount of current through them by just tying the inputs and outputs together, but also it has an inbuilt, they are Darling transistors, so a nice step up, but it has an inbuilt flyback diode, which for an inductive load would be great, so it doesn't zap everything on the way back, theoretically. I'm just going to build up step by step. I'm going to start with the buck converter and try and get 15 volts down to about 8 volts, nice and safely. Let's do this in stages. 15.5 volts coming in, and stage 1 reduction using a buck converter, 7.5 volts. Perfect. Let's put the next stage in. That's the linear voltage regulator. LM117 3.3 volt version, and so with reference to ground, let's see what's coming out. 3.3. Nice, everything's working. So I imagine that the ESP01 will go here, and then some lights and so forth. First thing I guess we've got to do is upgrade the ESP01's memory. Let's do that next. ESP01S with 1 megabyte of flash, according to ESP tool, and then I've got a 4 megabyte of flash ready to swap in. What I might do is use the old solder, high frequency soldering flash and go method. So I'll just get the frequency going properly. So the oscillations have worked. ESP tool reports that we now have 4 megabytes of flash. There's the old chip. And of course, you know, we've seen this before, so that's why I'm mucking around a little bit. But the next thing to do is I think I'm going to breadboard this whole thing. It's not a production model, it's just probably proof of concept sort of thing. So I'm going to use one of these breadboard friendly guys. Next stage is to just try a couple of LEDs, and let's put some power in and hopefully nothing blows up. And we've got one LED. Well, that's a good sign. And nothing has blown up. I suspect that I've got the pin numbers wrong. So let me go back and reprogram that, and we'll try again. The next stage is to hopefully get those pins right. And they are. Isn't that nice? There's another one going as well. Oh, I guess because that's pin, is it 0 or 2? Let's trace that. So it's going in concert with the green one. And the green one is going to trace this around. Yeah, pin 0. Okay, a little disconcerting. But anyway, I'm going to now put the shift register on here and see if I can't drive some of these just from a couple of, well, we need 3. We need 3 coming out. So I'll probably use something like TX on this side, which I think is pin 1. And we've got 0 and 2, and that should be enough to drive a shift register, which will pop in here. It's the next day, a little bit of coding overnight, mainly to figure out how do I shift this stuff out to the LEDs themselves. So I'll put the code up maybe here, just to show you how that's done, and I'll keep, obviously changing the code because we're not there yet. This is just another stage in the process. But here is my shift register, the old 74HC595N. Very cheap unit and very useful as it turns out. Coming out of the ESP01 here is my clock down here. So that's the orange line. And then data is the one coming out of what's labeled here GP2. And then I've got 0 is my latch pin coming into the shift register. Then you've got a pin here tied low and one tied high, and you can read for yourself, why that is. I'll put a diagram up here, but yeah, I mean, we've seen them on the blog and on the channel before, so it's not an unknown quantity. And then I've just got the 4 lines coming out, and I'll add to that when I have a look at how I want to actually build this whole thing. But the idea is that that we should, with those 3 lines, be able to affect 4 LEDs. So I might help if I turn the power on first. And let's give it 15.5 volts at this end. 3.3 volts on this rail. Still 15 on here because that's where the motor's going to go. And then I've just got a pattern here which is flashing each of these LEDs in a pattern and then all of them at once. And that was, as I said, just to get the timing and everything right. Pretty good. What do I need to throw in there? I think I want to put a buzzer in there. I think I want to put the motor in there. What I might actually do though is put the ULN2803 in next, just for one of these LEDs, to see if that chip is going to work with the voltage coming out of the shift register. So there'll be almost like a level shifter in the voltage as well. So let's tie that one up and see how it works. A few more bits and pieces have arrived. I did put a heatsink on this linear voltage regulator, and I'm even thinking of maybe winding this one down. I think it's 7.5 volts, and I might change it to something like 5.5 to give this one a bit of a break, going from 7.5 down to 3.3. Not that it was getting warm, not that there's a problem. It's still in the experimental phase, so yeah, probably everything should be okay. I've added, what have I added? So we've got our 4 wires going to our 4 LEDs, and I haven't changed the code for that. But I've got an active buzzer here, which if I've wired it up correctly, should go on for, I think, half a second or so. And then following that, there should be, I think, 5 seconds of bright LED action coming out of the ULN2803 if I've wired that one up correctly. Wow, exciting times. Okay, so let's put that in there and stand back Here we go. I did hear a buzzer. I don't see a light going on. 5 seconds of nothing. Okay. So everything seems to be working okay. I wonder if I've got the ULN2803 wired up correctly. Let me check that. A rookie mistake, I think, which was running this rail at the top here at 15.5 volts, which has been fine up to this point. But this is a pretty big LED. I think it's a 7-watt, which we've seen before on the channel for this sort of thing. So I've actually ramped that up now. That rail is now running at 20.5 volts, which should be fun when we hook up the motor to it as well. Anyway, let's just see how it goes. So that looks good. There's our buzzer, and there's our light coming on for, I think, 5 seconds as well. And then back to the flashing of the LEDs. Active buzzer. So I think that's pretty much proof that we can actually run all of this stuff from the ESP8266. The next is to hook the motor up and maybe do some sort of fake multitasking code so that we can run these processes one on top of the other. Good result so far. So far, so good. All these things are happening in a linear fashion. First that light, then that light, then that light, then that light, then the buzzer, and then that light, and then repeat. That's not really what I had in mind for like a door opening sequence, or maybe there's a pump about to go on. What else could be happening? Or maybe there's like a gate opener or something like that. Usually what you get is you have, let's say when nothing's happening, then everything is green. So normally a green light is on. Let's push this guy out of the way. So, and then maybe you push a button. I hope to eventually program this so the button is, this will be, the ESP01 will be acting as an AP, an access point. So you just log into that and press a button, and then green will go to red, and simultaneously we'll have the buzzer on. And then that will go for, let's say, 5 seconds to warn people that something's about to happen. And then if we have 2 yellow lights, I'm thinking of the scene in Aliens where Ripley is about to throw the alien out of the airlock, and there's like lights flashing and buzzers going. It's very exciting. So we'll have yellow 1 and yellow 2 just going backwards and forwards. And then maybe on yellow 2, we have the buzzer as well. So it's sort of, you know, in sequence with one of the yellows. And then at the same time as all this is going on, all of this is in relation to the motor actually turning. And so we'll make this maybe 5 seconds as well. And so the going backwards and forwards from yellow to yellow, probably something like, you know, maybe 200 milliseconds backwards and forwards, with this going for 200 milliseconds as well. Not really sure of the timing, something that you can affect. I guess the problem is, as is always the way with these little tiny controllers, and I'll bring this guy back into the frame again. The problem is that this one here, it's not multi-core. There's only one processor, if you like, inside there. So you've got to do this sort of pseudo multitasking. The way that you would do it is that you would have variables that are related to whether red is on or off, whether the buzzer is on or off, and then you would have whether the motor is on or off. And what you would do is that you would turn on, let's say, red, and you would then have a time that you're waiting for, so that it's looping. The whole thing's looping the whole time, maybe 100 times a second or something like that. And then it just checks, has 5 seconds passed, and we'll turn it off. And then the yellow, same with the yellow, yellow on, yellow off is just about what is going on while the clock is running. And then you would just measure, has 200 milliseconds passed? Yes, so turn it off and flip over to the other one. So a little bit of mucking around. The whole process, I imagine, probably takes about, 10 or 12 seconds, let's say. Actually not from green, because if nothing's happening, green is on. So maybe it's taking around about, let's say 10 to 12 seconds for the whole thing, and then it cycles through again. I might just set it up so it's doing that with maybe a 5 second break to see if the programming works. and then we'll come back and program the ESP01 to be an access point, and then see if we can operate it from our phone. The exciting thing, of course, is to replace this LED with a motor, and I don't want to do that until the last moment, just in case the inductive load kicks back and fries everything. It shouldn't. I mean, ideally, if I'm reading it right, the ULN2803 contains a flyback diode, so nothing should happen. I'm not sure what the motor will draw. I'll probably tie two of these together and two of the outputs together, because each of these outputs is 500 milliamps, and maybe we want to get something like an amp going for the motor running at, what's going to be around 20 volts out of its rated 24. But yeah, so I'll go and do a little bit of coding, and we'll come back and see how this is all running. Getting very close now. Couple of changes. I've got the shift register here with pin number 10, 10K resistor coming to the VCC or 3.3 volt rail with a 100 nanofarad capacitor between that pin and ground. The theory is that clears out the shift register before you start. Not that it really matters. This would be in a constant state once it's gone through the cycle or whatever, and it should be just a green light the whole time. When I turn it on, let's do that. Hopefully not too much weirdness will happen. There we go. Should go into green light once it's had a set up and into the loop. There's the green light. A few seconds later, we should get the buzzer in the red. And then our big load, and we've got our yellow lights going backwards and forwards, and then back to green again. I'll just turn that off. Or do we want to see one more cycle? No. No, it's too annoying. The last thing to do now is two things. I want to set this up as an access point, have my phone here, push a button, have that whole sequence go, and of course, the big ticket item, take out that 7 watt LED and put in the inductive load, the motor. Let's do it. The moment of truth, a little scary. I've added a 1000 microfarad capacitor there now that this thing is acting as an AP. Currently, I'm going to say the gate is closed, so this is sort of like an opening gate scenario. There's our motor connected. Let's go. Nice. And we have our gate open at this stage. So we press it again. Fantastic. Nothing has blown up. We're back to gate closed scenario. A lot to fix up in terms of the interface here, and obviously this isn't a gate, but nice that nothing's blown up. I'm going to call that the circuit working for this week. It's been a fun one. See you next time.